So here we go. Okay, so this is your number 124, and it's due the beginning of class next time. So let's go through a couple things. The nice thing about this packet is it is all the reading materials here for you. Excuse me. So we're going to zip right along to, look at the answers. Oh. Okay, so what we're going to do is focus in here on this diagram. It's usually called the HR diagram, and I want to bring a little bit more life to it than just a bunch of dots. Okay, so in your book, it looks like this. It's on page 626. Guys, stop. All right, so when you're looking at this diagram, this is a whole bunch of stars, and then they plot them out. And they're going to plot them out according to, so let's read, your luminosity, which is the brightness of light. So the energy of light, the energy emitted from the light is measured in lumens. That's the unit. And so if you see luminosity, it's the same as brightness. Okay, the more bright something is, the more luminous it is, the more luminosity it has. And then temperature. So if we look at this diagram right here, we can see that we have an increase in brightness. And usually the really, really bright stuff is super, super hot. And the cooler stars tend to be in that red spectrum. But we have red stars that are really, really bright. And so how does that happen? What happens there is that you'll look at the size then of the stars. And I'll move this a little sideways. So you'll look at the size of the stars. You can see here that these stars are really, really small, but they're pretty bright. Okay, up there. And then here they're super, super hot. Now these stars are not very bright and they're small. So it's kind of like up here, if you have a really, really bright LED light, I'm standing on a football field and you're at the other end and it's dark. So I'm going to flash a bright light, LED light at you. And at the other end, you're like, yeah, I can see that. They're pretty bright. Okay? So it's very luminous. And then we're going to have someone stand next to me and they're going to hold a candle. Candles are kind of cool. They have kind of an orange flame, right? So they're over here in this spectrum. And I have my LED light and my candle here. And you're like, did you light the candle? Hey, it's hard to see, okay? Now, what we do then to increase the brightness is we increase the size. So now instead of one candle, maybe we have 1,000 candles. It's still cool, but it takes up a bigger surface area. So now you're standing at the back of the football field and you're like, I can see that. And then it even gets bigger, okay, 2,000 candles. And then you're like, whoa, that's brighter than that LED light now. It's like, that's really bright. Now there's the LED light. So when you're looking at these and you're looking at stars, that's how these cool, dimmer type stars can become brighter because they increase in size. Okay, so we're in here, our sun's in here in the main sequence. So we're about right here when it comes to temperature and size. So we're kind of in the middle area. Okay, so when you're reading this diagram, you want to then align yourself with brightness or luminosity and temperature. Look high to low. A lot of times on these graphs, you go from low to high, right? 0 to 100 or 0 to 1,000. But on this diagram right here, you go low to high brightness, high to low temperature. So make sure you note that when you're answering your questions. So that'll help you answer those questions on that page. And then we'll get to the lives of stars, which is there, and star systems, galaxy, that one's pretty self-explanatory. And then the one I want you to go to next is this. So look for the distance to the galaxies. I want to distance to the galaxies page. I want to go ahead and explain these graphs to you so you understand how to answer the questions correctly, okay? So there's 2 steps to them. There's figure 1 and figure 2. You're going to use figure 1 and figure 2 to answer these questions. And what we're looking at is we're determining the brightness of variables A, B, C, and D, and E. And then once we determine the brightness, we then have the information to figure out the distance. And I'll step through that with you. So if you want to, write down the steps. Number 1, you're going to find the length of period in days, because that first graph is in days. And that's the information they provide you. 5 days. The second step, and then we'll find the brightness. So the second step then is to use that for figure 2 to figure out distance. And right here, distance is on the y-axis. And you can write in the answers if you want on the number 5. That way, if you get home and you forget and you don't have time to YouTube, you don't need to because you already wrote the answer, so you can refamiliarize yourself. Okay, here we go. Let's step through this first one. Step 1, I need to find the brightness. So it gives me days, so I find days. Days is on my x-axis. So I know 5 days, and they go in 20s. So I know half of 20 is 10, so I go halfway between, and I mark 10. And I go halfway between 0 and 10, and I get 5. So that's my 5 day, and I go up to the line. And then I go over to my y-axis, and I mark it. And then I determine what number is that in brightness. Well, they go in 5,000s. Half of 5,000 is 2,500. It's about halfway between. So halfway between 2,500 and 0 divided by 2 is 1,250. So that's where I get the 1,250 from. Questions on that? Okay. So then I take the 1,250 information and brightness and I determine my distance. So now I go down to figure 2. I go to 1,250, brightness, 1,250. Oh, got to do that thing again. So 5,000 divided by 2, 2,500, 2,500 divided by 2. So there's my 1,250 there. I go up to the line, and then I go over, and then I figure out what is that number probably. Well, these go in 400, so in between there halfway, it's going to be 600, and it's between 600 and 400 about halfway, so that's 500. So now the distance is 500 light years. Moving at the speed of light, it would take 500 years to get there, is what that's saying. Okay? Questions? So we're going to then go to the page where I wrote down what I want you to do. I'm going to have you take some notes and then answer a question and see how well you do. Ready? Okay. All right, on this next one, what I'm going to have you do is using the universe as a square and galaxies as a spiral shape and the solar system as the sun and a planet as a red dot. What I want you to do is draw those as they are in relationship to each other. So before we do that, we're going to do this little review. The universe, let me move this up. Okay, we have the universe. It's out there. It's expanding and creating space as it expands. Everything else is in the universe. Within the universe are billions and billions of galaxies. Different shapes, different places, all over the place. Okay, galaxies, billions of them. Within galaxies, ours is the
Milky Way.
Thank you. And then within that Milky Way, there's billions of stars. Our star, we call is the soul. It's the center of the solar system. Within that solar system, there's planets. So it goes from the really big picture down to the planets. Okay? Knowing that, Go ahead and use the square, the galaxy, the spiral, the sun, and a planet, a red dot, or just a circle if you don't have red. And draw those as they are in relationship to each other, like a kind of an abstract figure representing that. So take a moment to do that. And then I'll show you mine and see how well you did.
Like inside each other or what?
Probably. You shouldn't have a planet outside the universe. Right? Okay. Not that we, yeah. So let's get going. Chop, chop.
What's that? Oh wow.
I'm gonna draw it because I got pins on this shit. I don't know why I did that. I think they didn't have me to paint it. I looked over there. Another one.
Yep. You can just draw that.
Too slow.
Okay, you should be drawing.
I'm doing it. I drew it.
I'm going to go ahead and reveal what it should look like. Don't look up until you're ready to check your answer. Question?
Can I get a pencil?
You may?
Yeah, when I can borrow.
I don't. And I think I'm out. Does somebody have a pencil? For our friend?
Tomorrow does.
Thank you.
Yeah, tell me what. I'm sorry.
Yeah.
We don't know what I do.
You all look at ours, just like, I never,
You don't know how big your universe is.
everything's a square.
Nice. Yeah, nice loophole there.
Everything's a square, not a circle.
No, the universe is the square. That's why it's on a everything's within that. Within the universe are galaxies. Within the galaxies are stars or our solar system. Within our solar system is that. Okay. Now, if you had the question where it said the galaxies are triangles and the solar system is a trapezoid and planets are an exclamation mark, you should still be able to draw that representation of each other. Okay? So this assignment is due at the beginning of class next time. Have it ready to go.